Hi everyone, in this video we are going to be discussing Ka. Ka is the acid dissociation constant for a given acid-base reaction. We are going to consider having a generic acid here, Ha, in an aqueous solution. Our solution is water. We are putting our acid in water, and what could happen here is that water would deprotonate to form hydronium, or we could say H plus aqueous, and the acid would become deprotonated, and then we would have its conjugate base species A minus in solution. And the extent to which we could quantify the dissociation of our acid Ha can be calculated by this equation here. You take the concentration of your H plus aqueous multiplied by the concentration of your conjugate base divided by the concentration at equilibrium of your acid Ha that is left. So remember, this Ha can dissociate into H plus and A minus, but then A minus could take back the proton to become Ha. There is a back and forth that can occur. So it's not that acidic species always just gives off that proton and it's there in solution. There is a back and forth. The important thing to note here, and keep in mind that this is all relative because we're usually making a comparison between two species, two acids. A species with a larger Ka will dissociate more readily. It would be a stronger acid, and it might be more product favored than a species with a smaller Ka. A smaller Ka means that the acid does not dissociate as readily, and a really small Ka might mean that the acid-base reaction is actually reactant favored, and that the dissociation of the proton from the acid is not very likely. Okay? So if you're looking at two acids, the one with the larger Ka is the more acidic acid. The one with the smaller Ka is the less acidic acid. And if Ka is very small, it's going to possibly be a reactant-favored acid-base reaction. So again, Ka describes the extent to which an acid dissociates in solution. However, in organic chemistry, we will talk more about pKa. And I'm going to make a separate video on pKa. pKa values are a little bit more digestible. Ka values are usually described by 10 raised to some exponent, 10 to the 3, 10 to the negative 4, and those are harder values to really comprehend. And so what we do is we calculate pKa to have something more tangible, some integers to work with. Again, hang tight for that video segment.